We're standing in the porch to the entrance of Russell Hall on 120th Street in front of Teachers College. Behind me is the stonework, which is the trim on virtually all the Teachers College buildings. It's a rich, reddish, chocolatey sandstone, which is characteristic of many building stones throughout the metropolitan region. The brownstones of Brooklyn are made of the same sort of material, although that's a little bit deeper chocolatey color, and this is a rather lighter pinky color. These rocks are quarried from the Mesozoic sediments of the Newark Basin on our west and the Hartford Basin on our east. They are both complementary halves of a great subsidence trough that developed when North America and Africa were separated by the birth of the Atlantic Ocean during the Mesozoic period. This is the material on which dinosaurs were stomping around and leaving their tracks. For the first half of Earth history, that's up until about 2.2 billion years ago, there were no red sediments at all. It is only subsequent to that era, at the end of the Archean period and the start of the Proterozoic period, where a lot of red sediments were deposited, that any red sediments are preserved in the record at all, which suggests, in fact, that something has happened to the environment of the Earth that would change the ability of sediments to be only black or gray or green or some drab color to becoming brown to red. The pigmentation of all the red sediments are iron oxides and oxyhydroxides, which incorporate 3+ iron. That's what gives it its red color. In the same way, your blood has 3+ iron in the hemoglobin, which gives it the red color. The occurrence of red sediments in the geological record indicates a time when something happened to our environment, when oxygen became free in order to oxidize materials that were being weathered from their 2+ native states of the metal in their 2+ valence into 3+ and develop the pigmentation. So the presence of red sediments is an indication that the atmosphere of the Earth was safe for life as we know it to exist, which requires free oxygen in order to support the metabolism of air-breathing organisms. The dividing line between sediments in the record which show you the red color and those sediments which do not show the red color at about 2.2 billion years coincides with the great oxygenation event in which presumably photosynthetic metabolism organisms began producing net oxygen that accumulated in the atmosphere, indicating a very sea change in the life forms that existed before that time and after that time. If it weren't for the plants, we would be toast.